Hey, welcome back, everybody. That's 5.3.1. Let's go over and get some answers here. Okay, first off, that first question, we were just getting the area of a rectangle. Remember, you care how wide it is times how tall it is. Now, when we measure how tall something is, it's got to be straight up and down, right? If you were, right, here and they want to measure you, they don't use rulers, a tape measure, and measure at an angle like that, right? They can make you 10 feet tall if they did that, huh? You got to go straight up and down. Okay, so as far as this rectangle went, we care about this and this, the two lines that make that right angle or 90 degrees. And one of them was 10, and the other one could have been B or C, right? So it could be 10 times C or 10 times B, not D. Right? Now I could do D times C and D times B, right? But we already know D, that is the same as 10, opposite sides of a rectangle. Okay, are they going to be the same length? Actually, opposite sides of a parallelogram, right? Parallelogram. Here's something for you here. Okay, this is a parallelogram. This will be the same length as this, right? If I drew it right. And this will be the same length as this. Now, what's the area of a parallelogram? Well, check this out. If I chopped off this triangle right here, I could slide it over here and it would fit in perfectly right there. What's the area of that? How wide is it? Times how tall is it? So the area of a parallelogram is going to be similar, right? How wide is it times how tall? What you don't care about, a rectangle, how tall it is one of the sides. A parallelogram, how tall it is not one of the sides. So that's where you have to be careful. Okay? But anyway, so the correct answer is 10 times C or 10 times B. And the reason is you're going to try to explain it like you have a third grade brother and put it in simple terms that you need to know how wide it is times how tall it is. Okay? All right. Now, I told you on that next one that Zach, when we were figuring out a mathematical equation, right, that it was on here. Where is it? It was here. What does of mean in math? If you don't immediately say of means multiply, then write it again in pen, big, right? So you know, all right? So if I wrote 3/5 of 2/3 cup, what you can do is write that and then put a big X through the of, so you know you're multiplying. So 3 times 2 is 6, 5 times 3 is 15, and 3 went into the top and bottom 2 times and 5 times. So he has 2/5 of a cup of brown sugar. Okay? We answer all those questions, drew the diagram. Yeah, okay. And we were going to, on B, represent, if this is 2/3 of a cup, what is how much he has? He has 3/5 of that. And I said to go ahead and shade in 3 of the 5 columns. Okay? Okay, so he has 2/3. Now, if we wanted to, if I made a rectangle that was 3 by 5, those are the two denominators, right? There are 15 total squares in there. If I said, okay, that he needed this 2/3, but he only had 3/5 of that, what's double shaded? Right here. And what's that? 1, 2, 3, 4, 5, 6 15ths. Boom. Right? Which we figured out is the same as 2/5. Kind of cool, huh? All right. 1 cat to 16 whiskers. 7 cats is going to be 7 times 16. 7 tens is 70. 7 sixes is 42. 70 and 42 is 112. And you can go double check that. 16 and 7, 42, 7, 4, 11. Okay. 3 is to 6, like 2 is to how much? Okay. 3. All right. So here's the deal on this one. 3 is to 6. Can I simplify that? 1 to 2. So 1 to 2 is 2 to 4. Okay. Similar here. 8 is to 64. Can I simplify that? Yeah, that's the same as 1/8. 1 to 8. And they want to know 5 is to how many? Well, 1 times 5, 8 times 5. It's going to be 40. Okay. 5 spiders is 40 legs. All right. Back to my red one here. All right. So Jack is over 1 up 2, over 3 up 1, over 3 up 2, and over 4 up 3. 4, 3. Make sure you have 4, 3 and not a 3, 4. Okay. There's a difference. Okay. Ask your buddy in the Army. If you've been paying attention to me, you know what that is, and you're probably chuckling right now. So we have the 1, 2, and 1, 1, 1, and 1, 2. Sorry, 1, 1, and 2, 1. Now I need 2, 2, and 2, 3. Now, where could Jill go next to get her Connect 4? Well, most of you saw 3 in a row right here, right? So she can go up here. And what's that? That's not 4. It's over 2, up 4. She can go to 4. Can she go anywhere else? Yeah, she could have gone over 2 and up 0. See that? All right, there any other ways? I don't see any other ways for her to get 4. Okay. This type of problem will come up again, though. These are kind of fun, so I'm glad they came up. Now, if you did our warm-up, then you've already done this, but this was going to be 30 and 4, 90 and 1, 3 times 9 is 27, but move the decimal over twice. 9 times 4 is 36. Move the decimal over once for that 0. 4 times 1 is easy, and 30 times 1 is easy. So 2,700, 360, 30, and 4. Okay, 3,094. Now, you want to double check? Do the standard algorithm. Doesn't take long, right? It's good practice anyway. Placeholder, because that's really 30. 3 times 1, 3 times 7, 9, 3 times 9. And same answer, so we're going to say yes, we did it right. Okay, this one, 3 digits times 2 digits. So I'm going to make this rectangle a little bit longer because I want to have 420 and 1. And here I'm going to have 90 and 6. 9 times 4 is 36, but move the decimal over 3 spots, so 36,000. 6 times 4 is 24. Move the decimal over 2 spots for those 2 zeros. 9 times 2 is 18. Move it over 2 spots, so 1,800. 6 times 20 is 120. 6 times 1 and 1 times 90. 6 products to write to add up, right? Get the sum of 6 products. So I'm going to add the answer to 6 multiplication problems. And 1,800, 2,400, 120, 90, and 6. So 6, 11, carry the 1, 9, 13, 14, 7, 8, 10. Is that right? 40,416. And let's just double check. 42196. 6, 12, carry the 1, 24, 25. Placeholder, because that's really 90. 9, 18, carry the 1, 36, and 1 is 37. 6, 11, 14, 10, 40,416. Same answer. Must have done it right. Okay. Hopefully that helped you. Hopefully you did well. Hopefully tonight's homework is just as easy for you. Okay. All right. Have a good one, everybody.